Can you hear me?
Yes.
Okay, so in the last class, we were looking at some inequalities.
Yes.
I gave you one problem, one or two problems, right?
Yeah.
So one of them was this question. Let A be a real number. A is greater than 2. You have to prove that A cube into A minus 2 whole square plus 2 by A minus 2 is greater than equal to 3A,
Yeah.
right?
Yes.
Did you get anything here?
I did.
You did
So
or did not?
I did.
What?
So I pretty much said that since a minus 2 squared will always be positive and
Mm-hmm.
greater than 1, and then
Why will it
2
be
over
greater than 1? How do you know it will be
because
greater than 1? It is a real number, it is not an integer. A can be 2.1 also, no?
oh yes you can.
So what will be A minus 2 whole square then? It will be 0.01.
Yeah.
So it is not greater than 1 necessarily. What you know is A minus 2 whole square is greater than 0.
Yeah.
But you can't say it is greater than 1, right?
Yeah. Yes.
What have you done?
Oh well then what I kind of do is kind of use
You should simplify it like this. First of all, I should add it because you can see an A minus 2 here. If you add these two fractions, what will you get? Here it will be A minus 2 to the power
oh
what?
you get 3.
Plus 2, right?
Yes.
Is greater than 3A. This is what we want to prove. Now, here we know that A minus 2 is positive, right?
Yes.
So if I multiply both sides by A minus 2, the inequality is not going to be changed, correct?
Yeah, it won't change.
If you are multiplying by a positive thing, both sides, then nothing changes. So we can write it like this: A minus 2 whole cube plus 2 greater than equal to 3A into A minus 2, right?
Yes.
Great. So we need to prove this. And now you can think of one simple thing. You can see here there is a into A minus 2, and here also there is a in A minus 2, right?
Yeah.
So let's call B
Yes.
as a new variable, which is A into A minus 2. So left hand side becomes what? B cube. Do you see this?
Yeah.
We have this situation is happening, right?
Yes.
Because this is clearly B cube. This is B. We need to prove
Yeah.
this inequality. And we know that B is positive because this is positive, this is positive.
Yes.
We know B is greater than 0 is known. We have to prove this.
Yeah.
Okay. So now what I will do is I will bring everything to one side and think about that expression. If I can show that it is greater than 0, then it is over.
Yes.
So let's see what we can do there. So we'll say B cube minus 3B plus 2. And we'll try to think of this expression and try to prove that it is greater than 0.
Yeah.
Okay. So first of all, can we factorize it? Do you know something called factor theorem?
No.
Factor theorem and remainder theorem you don't know?
Uh, I think I've heard of it, although
If you have an algebraic expression and you want to think of factors, factor theorem says that if f of a is equal to 0, then x minus a is a factor of f of x. Basically, it's simple only. If I have a quadratic x squared minus 3x plus 2, you can see that if this is called f of x, f of 1, what is the value of f of 1?
1 minus 0.
What is the value of f of 2?
4 minus 6. Oh, also 0.
So can you see that clearly f of 1 is 0, f of 2 is 0, and factor theorem says that x minus 1 and x minus 2 are factors now.
Oh,
It is obvious that factorization of this is x minus 1 into x minus 2.
yeah.
The reason the theorem works is because if you have any function, let's say some constants like this, plus here all the a's are coefficients, they are constants. This is my general polynomial. Do you understand what
Yeah.
I'm saying?
Yes.
All the a's are some numbers, right?
Yes.
Now, if if it can be factorized like this, x minus alpha, x minus beta, x minus gamma, and so on, and maybe at the end you will be left with some lowered polynomial. Suppose I have factorized it like this, three factors are coming out, then what is the degree of the polynomial inside here?
N minus 3.
Right. So that n minus 3 polynomial I can write like this: bn minus 3 x power n minus 3 plus bn minus 2 x power n minus 2 and so on, right?
Yes.
What I have said right now is that maybe there were three factors that can be taken out, right?
Yes.
And the remaining one is you cannot take factors from here, right?
Yeah.
If this was my function, it is obvious that if you put alpha into the function, what is the value of f of alpha?
0.
What is the value of f of beta?
0.
What is the value of f of gamma?
0.
Because these factors are becoming zero, right?
Yes.
So that proves my factor theorem, correct?
Yes.
That if you can see which values the function is becoming zero, if I knew this, then I could have said x minus alpha, x minus beta, x minus gamma are factors, right?
Yes.
So that is a very useful theorem because many times you will get cubics like this situation. I have a cubic right now, right?
Yes.
But if I can guess f of 3 is 0, suppose, I don't know. If f of 3 was 0, I can say b minus 3 is a factor, right?
Yes.
But now what I will do is I will check. Let's check for small values. Put b is equal to 1 and see what happens.
You get 0. Because you get 1 minus 3 plus 2.
So it is.
0.
So don't you think that b minus 1 is a factor?
Yes.
Do you understand what I'm saying?
Yeah.
So given a polynomial, if you know a particular value at which it is vanishing, then you know the corresponding factor, right?
Yes.
Is it clear?
Yeah.
So now I know that b minus 1 is a factor of this, right?
Yes.
So what I will do is I will divide by b minus 1 and the remaining thing will be a quadratic that will remain, right?
Yes.
So let's do that. So I'll say b square into b minus 1 minus b square. So plus b into b minus 1 minus b and minus 2 into b minus 1. So I'm doing the division only. So I'm getting b minus 1, b square plus b minus 2, right?
Yeah.
You can multiply and check. That is the same thing as this. Okay. This is just division. I have just done division.
Okay.
And I have taken out b minus 1, right?
Yeah.
Now this part inside can also be further factorized. For example, if you put 1 here for b, see again it is becoming 0.
Yeah.
So that tells me that there is another b minus 1 coming from here, no?
Yes.
So I'll get b minus 1. And when I divide this by b minus 1, I will get b into b minus 1 plus 2b minus 1. So what I'm getting is basically b minus 1, b minus 1, and b plus 2, right?
Yeah.
So this is the same thing as this, and clearly this is positive, and this is also positive.
Oh, yes.
So this is positive. So our question is over now
Oh,
because
okay.
we had to prove what? We had to prove bq plus 2 is greater than 3b.
Yeah.
Do you understand what I have done?
Yes.
So basically, what we had to do here was don't worry about the a's so much. Combine them. You will see that a into a minus 2 is there on both sides. So you can take it as a variable b or x, whatever you want. Then
Yeah.
you will end up with a cubic like this. X square, x cube plus 2 is greater than 3x. That's what we have to prove. And that can be done by factorizing this expression. Came out as x minus 1 whole square into x plus 2.
Yes.
Do you understand?
Yeah.
Okay. The next question was, let x and y be non-negative integers, non-negative real numbers, be non-negative reals. And you have to prove that 1 by 1 plus x whole square plus 1 by 1 plus y whole square is greater than equal to 1 by 1 plus xy. Did you
Yeah.
try this one?
I tried it, but I could not solve it.
There is no mystery to this solution. All you have to do is bring everything to one side and simplify. There is nothing else we can do. So what we will do here is 1 by 1 plus x whole square plus 1 by 1 plus y whole square minus 1 by 1 plus xy. Right?
Yes.
How do I simplify it? My common denominator is going to be 1 by x plus this. This is my common denominator, right?
Yeah.
So the term that comes first term will be 1 plus y whole square into 1 plus xy. Then second term is 1 plus x whole square into 1 plus xy. And the subtraction will be 1 plus x whole square into 1 plus y whole square. Right?
Yeah. Yes.
So now we just have to simplify it. There is no other solution to it. So let's try it out. We will get 1 plus y whole square, 1 plus xy plus 1 plus x whole square into 1 plus xy minus 1 plus x whole square, 1 plus y whole square. This is the numerator, and the denominator was what? Denominator was 1 plus x whole square, 1 plus y whole square, 1 plus xy.
Yeah.
Now, we don't need to worry about the denominator because this is positive, and the question had said that x and y are non-negative, right?
Yes.
So this is also positive.
Yeah.
The third term is also positive. So all we have to worry about is the numerator, right?
Yes.
If I can prove that the numerator is positive, then the whole thing is positive, and then the question is over.
Yes.
Okay, so let's simplify this, and this becomes, let's see. So 1 plus y whole square plus xy into 1 plus y whole square plus 1 plus x whole square plus xy into 1 plus x whole square minus 1 plus x whole square 1 plus y whole square, right?
Oh, okay. Yeah.
So we can say that, okay, so we will have to simplify it further. So we'll say 1 plus y square plus 2y plus, this will be 1 plus y square plus 2y multiplied by xy. So it will be xy plus xy cube plus 2y into xy. So 2xy square, right?
Yeah.
Here you get this plus xy plus x cube y plus 2x square y, right?
Yeah.
Minus, you will get 1 plus x square plus 2x multiplied by 1 plus y square plus 2y. So let's write the negative terms here. All of this multiplication we'll write on the bottom here. So minus 1 minus y square minus 2y minus x square minus x square y square minus x 2x square y minus 2x minus 2xy square and minus 4xy. Do you understand what I have done?
Yes.
So I have written all of those terms here. So now see, this is cancelling this is cancelling this is cancelling this, right? Then x square is getting cancelled. X square y is here, minus, this is getting cancelled. X y square is here, this is getting cancelled, right?
Yes.
2x is there getting cancelled. And you are getting a plus 2xy here. This is this and this. And there is a minus 2xy here, minus 4xy here, right?
Yes.
So what terms are left? Only this term, these two terms, this term, and this term, right?
Yeah.
So we are getting what? Xy cube plus x cube y plus 2xy minus 4xy. So minus 2xy and minus x square y square. Correct?
Yeah. Yes.
Okay. So now here what I can say is, oh wait, a plus one is also there. This plus one, right?
Oh, yeah.
1 plus. So minus x square y square is there here. Right. So this minus x square y square I can write as plus x square y square minus 2x square y square, right?
Oh, yes.
So what I'm doing is going to write it like that because that will help me because now I can make a perfect square.
Oh,
See,
okay.
which perfect square? I'll make a perfect square with this term, and this term. Can you see?
Oh, yes, yes.
So I will get a xy minus 1 whole square, right, from these three.
Yes.
And now the remaining terms are what? See, this term, and this term, right? So
Yes.
from there, I can take a xy common.
Yes.
I will get y square plus x square minus 2xy.
Oh, yeah.
So I'm getting xy minus 1 whole square plus xy common and x minus y whole square, right?
Yes.
So now it is very nice because this is a perfect square, this is a perfect square and multiplied with positive things. So it is guaranteed that the overall expression here is greater than equal to 0.
Yes.
Do you understand what we have done?
Yeah.
Nothing very smart. We just brought everything to one side, simplified it, and when we got to this step, we just wrote it as perfect squares.
Yeah.
And that finishes off this proof. Now, next problem is this one. Question 3. You have, if x is a real number, you have to prove that x cube minus x is less than equal to root 2 over 4 times x power 4 plus 1. Okay, try it out. I would say first step would be to check if x is 0, is the inequality true? If
Oh,
x is 0, is the inequality true?
no.
It is true, no? Why is it not true?
Oh, it is true.
This is not true.
It is true.
So the inequality is valid for x is equal to 0. And now, why did we check x is equal to 0? Because in the next step, I want to divide by x and all.
Yes.
Because I cannot divide by x if x could have been 0, right?
Yeah.
So the next step, I have already checked for 0. So now I will say suppose x is not 0, right?
Yeah.
So if x is not 0, I want to divide by x and all because this form is weird. I don't want to deal with fourth degree, third degree terms and all.
Yeah.
I hate that. I don't want it. So there is a nice way to make it easier. You should divide by x square on both sides. Why are we dividing by x square and not x?
So that you don't get a x cubed.
That is one reason, but you have to be careful by what you divide because we don't know whether x is
Oh, you don't
positive
know.
or negative.
Yeah.
If x was negative, then dividing would change the inequality rate.
Yes.
So it is better to divide by what?
X squared.
Because that will keep the inequality sign, right?
Yes.
So if you divide by x square on both sides, there is nothing to worry in terms of the sign of the inequality. So I will get x minus 1 by x less than equal to root 2 over 4 x square plus 1 by x square.
Yes.
This is a much better thing to try to prove because if you know x minus 1 by x whole square itself is what?
Oh.
So basically you can relate this side as x minus x 1 by x whole square plus 2, right?
Yeah.
This is a simple identity. So we can say x square plus 1 by x square is equal to x minus 1 by x whole square plus 2. Correct?
Yeah. Yes.
So the inequality here becomes x minus 1 by x is less than equal to root 2 over 4 and x minus 1 by x whole square plus 2, right?
Yeah.
And now it is normal to try to take this as a variable, right? This is there on both sides.
Yes.
So we'll say, let's call t is equal to x minus 1 by x. The inequality that we want to prove is t is less than equal to root 2 over 4 t square plus 2. Correct?
Yes.
Do you understand what I'm saying?
Yes.
Okay, so I'll write that on the next screen. T is less than equal to root 2 over 4 t square plus 2. That is what I want to prove. So simplifying it a little bit, t is less than equal to this is 1 by 2 root 2 t square plus 2, right?
Yeah.
So since 2 root 2 is positive, I can multiply both sides. So 2 root 2 t is less than equal to t square plus 2, right? So
Yes.
what I want to prove is t square minus 2 root 2 t plus 2 is greater than equal to 0,
Oh, yes.
right?
Yeah.
Can you see why this is correct?
Yes.
Why?
Because it's t minus root 2 whole squared.
Which is obviously greater than 0.
Yes.
So now you will reverse all the steps and you can say because this is true, and therefore this will be true, right?
Yes.
And therefore the starting inequality that I needed is done.
Yes.
So the key step was first checking that x is equal to 0 works. Then after that we said that now we can divide by x square, not dividing it by x, dividing it by x square, because
Yeah.
that ensures that we don't have to worry about the sign.
Mm.
As soon as you divided by x square, you got x minus 1 by x on one side, and on the other side, you got x square plus 1 by x square. But x square plus 1 by x square can be written in terms of x minus 1 by x.
Yes.
And after that, it was changing the variable to t, and it's obvious after that.
Yes.
Is it clear?
Yes.
Okay. Question 3 is this one. Let A be a non-negative real number, you have to prove that 1 plus a square over 1 plus a is greater than equal to cube root of 1 plus a cube over 2. Okay, try it. Try what you can do. See what you can do here.
Okay. Mm. Mm. Um,
You should start by cubing both sides to remove this.
yeah,
You will get this by 1 plus a whole cube is greater than equal to 1 plus a cube by 2.
yeah,
Okay, so then we know a is non-negative, so therefore 1 plus a is positive, right?
yeah,
All of these terms are individually positive, so I can cross multiply without worrying about it. Correct?
yeah, yeah,
So I can say 2 times 1 plus a square whole cube is greater than 1 plus a whole cube times 1 plus a cube, right?
yeah.
Now just simplify it normally. Do you know how to do the cubic formulas and all?
Uh,
You know x plus y whole cube, what is it?
it's x plus y times uh x squared plus 2x y plus y squared, which will be
That's not
x.
what you need to remember. You need to remember the actual formulas. What you are saying is common sense, but that is not helpful. The actual formula is this. This has never been seen in your maths classes before.
Oh no! Oh yes, yes, I remember that now.
These are the formulas that are important.
Yeah,
So I will say here 1 plus a square whole cube will be 1 plus a power 6 plus 3a square 1 plus a square is
yeah,
greater than equal to, here I will say 1 plus a cube plus 3a 1 plus a multiplied by 1 plus a cube. So this becomes 1 plus a cube plus 3a square plus 3a multiplied by 1 plus a cube. And on this side, I get 2 plus 2a power 6 plus 6a square plus 6a power 4, right?
yeah,
We have to simplify it. So right hand side, you have to multiply correctly without making any mistakes and then bring it to the left hand side. So let's do that. You will get 1 plus a cube plus 3a square plus 3a plus a cube plus a power 6 plus 3a power 5 plus 3a power 4, right?
yes,
On this side, you have this stuff, correct?
yes,
Okay, so a power 6 will get cancelled. The 2 will go. It will become a simple a power 6, right?
yes,
6a square is here and there is 3a square here. That will get cancelled. This will become a 3a square.
yes,
6a power 4 is here. There is a 3a power 4 here. So this will become a 3a power 4, right?
yes,
The 1 will go and this will become a 1. And the remaining terms will come on this side with negative sign,
yes,
right?
yes,
So you will end up with the inequality that you need to prove will become a power 6. A power 6 here is the highest power minus 3a power 5 from this side plus 3a power 4. Notice that there is a cube and a cube here.
yes,
So minus 2a cube. There is a
yeah,
plus 3a square here. And then there is a 3a here, right?
yes,
And then there is a plus 1 here.
yeah,
This is the sequence that we are getting, right?
yes, yes,
So it is difficult to say anything about this without having factorization. Do you
yeah,
understand what I'm saying?
yes.
So it is a sixth degree term, so it's not like it will be very easy to factorize, no?
It won't.
It won't be very easy unless you can see that
Oh,
if
oh,
factor
yeah,
theorem, if you know, then you can do it, right?
yeah.
So,
Couldn't you, couldn't you split the 2a cubed into minus a cubed and minus a cubed, and then you have just two cubes?
mhm.
Oh wait, but that won't be very helpful.
No, it will be helpful actually. If you do that, you will get a minus a cube, and let's group these two, and there is a remaining minus a cube, you can say minus a cube plus 1, right?
Oh,
And then you
yeah,
can group this one with this one. And you can group this one with this one.
yeah,
Do you understand what I'm saying?
yes,
This is the same thing as this, the same number of term. We have just increased the term by 1.
yes,
But the advantage is we have handled this, we have handled this, and we have already handled these,
yes,
right? So
yes,
notice here that you're getting a cube common a cube minus 1, minus 1 common a cube minus 1, right?
yes,
And here minus 3a square a cube minus 1.
yes,
And here plus 3a a cube minus 1.
yes,
So clearly this term is a cube minus 1 whole square. And then you have a minus 3a square a cube minus 1 plus 3a a cube minus 1, right?
yes.
So taking a cube minus 1 whole common, you'll get a cube minus 1 minus 3a square plus 3a,
Oh,
right?
yes, yes,
This is a cube minus 3a square plus 3a minus 1, which is actually a minus 1 whole cube.
yes,
So it is becoming a cube minus 1 into a minus 1 whole cube, right?
yes, yes,
Now at this stage, you should also know the identity a cube minus b cube is equal to a minus b into a square plus ab plus b square.
yeah, yeah, I know that.
So here it is a cube minus 1. So we can write it as a minus 1 a square plus a plus 1, right?
Yes,
And now this a minus 1 whole cube and this can combine and become a minus 1 whole power 4 and a square plus a plus
yes,
1.
yes,
We didn't know whether a was bigger than 1 or not. So it is not good to have this term or this term because we don't know the sign.
yeah,
But it is great to have this term because
yes,
this is always greater than 0.
yes,
And it is also good to have this term because look at the discriminant of this quadratic, it is negative 1 minus 4.
oh, yes,
If discriminant is negative, the quadratic is always positive, it has no real roots.
yes,
Or you can write it like this a plus half whole square plus 3 by 4.
oh, yeah,
Completing the squares here, you will get a plus half whole square will give us these two terms plus 1 by 4 plus 3 by 4, right?
yeah,
So clearly this is greater than 3 by 4, right?
yes,
So this is also positive, this is also positive, and therefore this is positive. And
yes,
the question is done because we needed to prove that big sixth degree thing was positive, right?
yes,
Do you understand what is happening?
yes,
So factorization is a very important idea here. If you couldn't think of that factorization, then you should have tried putting a is equal to 1. You would have realized that a minus 1 is a factor.
what?
By
Eight,
using factor theorem.
2, 1.
Here, if you had not spotted that we can split 2a cube, what would you do?
Oh, oh, over there. Then you,
How would you factorize this if you don't, if you forgot to spot this, that this can be split like this, and the way we have factorized it is unique and it's not necessary that you would have gotten it.
yeah,
If you had not gotten it, what would you do?
then you use factor theorem.
We use factor theorem by saying, let's try whether a is equal to 1 is a factor or not. If you put a is equal to 1, you'll get 1 minus 3 plus 3 minus 2 plus 3 minus 3 plus 1. What is
Yeah,
this? This
that's
is
just,
clearly 0.
yes,
This tells us that a minus 1 is a factor. If a minus 1 is a factor, I can divide this by a minus 1 and I will get a fifth degree thing, right?
Yes.
So I can write it as a minus 1 and a power 5 and stuff, right?
Yes.
Then I will check here and then I will check here again and I will see whether a is equal to 1 or 2 or minus 1 or something is a factor.
Yes.
You will realize that again a minus 1 will come out from here
Oh, okay.
because ultimately we got it as a minus 1 whole power 4 and a square plus a plus 1, right?
Oh, yes, we did. Yes.
So that means
Oh,
if even if I had done this and I would have gotten a fifth degree term, I could have
yeah.
gotten an a minus 1 out of this also.
Yes.
And then again, 2 times more, you can get a minus 1 out, right?
Yes. Yes.
So if you had done all that, you would end up with a quadratic. That
Yeah.
doesn't require any clever thinking if you know factor theorem. The way we did
Yeah.
it in the actual problem requires clever thinking of splitting this and grouping it with this term and grouping it with this term and grouping the a power 5 term with the a square term and a power
Yeah.
4 term with the a term, right?
Yes.
It is not necessary that you would have figured that grouping out normally, right?
Yeah.
But factor theorem anybody can use. There is no need for very smart people for that. It's very simple.
Yeah.
Do you understand what I'm saying?
Yeah.
Okay. I will give you 2, 3 problems that you need to try for next week. Try it properly. Don't give up quickly.
Yeah.
So the first one is this. Let A, B, C, D be real numbers. Not all of them are equal. Not all of them are equal means maybe some of them could be equal, right? It
Yeah.
is possible that 1 or 2 of them might be equal, but not all of them are equal, right?
Yeah.
Prove that at least one of the numbers a minus b square, b minus c square, c minus d square, and d minus a square is less than 1 over 4. Prove that at least one of the numbers is less than 1 over 4. Remember that we have done questions like this in the past. In the
Yeah.
previous weeks, we have done things like prove that at least one of the 3 things is something, right?
Yes.
Every
You
time we have done a question like this, the method of proof has always been what method?
you assume that none of them are
So
less.
method of proof is usually proof by contradiction, right?
Yes.
We'll assume the opposite and then we'll come to a contradiction somehow, right? So
Yeah.
that is the hint that you should try contradiction here somehow. Correct?
Yes. Yes.
Then the second problem is this. Find all triples x, y, z of real numbers such that 2x square plus 3y square plus 6z square is equal to 2 times of x plus y plus z minus 1. Okay?
Yeah.
Write down these problems. Problem 3 is solve in real numbers the equation. Solve in real numbers the equation root x plus root y plus 2 times root of z minus 2 plus root v plus root t is equal to x plus y plus z plus v plus t. Write down the problem. If you have written all three, then tell me. I have a couple more questions.
Yeah, I've written them.
Okay. Then problem 4 says solve in real numbers. Solve in real numbers the equation root over x1 minus 1 square plus root over twice of x2 minus 2 square plus 3 times x3 minus 3 square, and so on. You go on till n times root over xn minus n square is equal to half of x1 plus x2 plus xn. Basically, you have to solve this equation for basically values of the variables x1, x2, xn.
Oh, okay.
There is a single equation and so many variables are given. So something special has to happen, right?
Yes.
Think of inequalities, what is, think of when is the equation properly defined.
Oh,
You cannot, if you are talking about real numbers, can you have negative things inside a square?
no.
So obviously all of the roots have to be, things inside the roots have to be positive, right?
Yes.
So think of that. That will be helpful in finding the solution.
Yes.
Do you understand what I'm saying?
Yes.
And last problem is this one. Find all triples A, B, C such that triples ABC of real numbers greater than 1 such that A times root over B minus 1 plus B times root over C minus 1 plus C times root over A minus 1 is equal to AB plus BC plus CA over 2. So the answers that you need in this question are real numbers bigger than 1, which will satisfy this condition.
Yes.
Write down the problems, and these 5 problems, make sure you try them in the week.
Yes.
Only if you try it yourself, then when you see the solution, then you will really understand. If you
Yeah.
don't try them, then it's not useful for you, right?
Yeah. Yeah.
Okay, fine. That's all for now. We'll continue in the next class.
Okay. Thank you.
Hmm.